This is a reteach video for properties of exponents, but we are going to use and focus on the expanded form that might help you more understand the rules that we've been teaching you in class. So the expanded form is taking the exponents and writing them out as many times as they exist. So we know that x squared is x times x. We're going to use that idea that x times x, because it's happening twice, if this was x to the third power, there'd be another x here, to talk about our different rules. The first problem says 2m squared times 2m cubed. If I write this in expanded form, I have 2m squared times 2m cubed. Okay. I want to combine together the multiplication for each type of letter or number here. Now I have two 2's, that's going to be 2 squared, or just straight up multiply. 2 times 2, that's 4. And if I counted up the number of m's I have, I'd have 1, 2, 3, 4, 5 m's total. This is 4m to the 5th power. We treat numbers like we've always treated numbers, and we treat exponents like we've learned to treat exponents, where if we're multiplying the bases, we add the exponents. Multiply any base, which means add the exponents. Now if we look at problem number 2, which is m to the 4th times 2m to the negative 3, before I can do expanded form, I do need to change this particular problem using the negative exponent rule. The negative exponent rule says that if I have a negative exponent, then that piece and that piece only gets to be flipped. This problem is actually m to the 4th times 2 over m cubed. Here's the expanded form for this problem. I'd have a 2 and a 1, 2, 3, 4 m's in a numerator, and then 1, 2, 3, oh, just kidding, there's only 3. 1, 2, 3 m's. Now, just like we know 5 over 5 is equal to 1 because it cancels out, I can cancel out anything that has a top and a bottom that are exactly the same. M over m. So all I'm left with at the very end here is 2m. Which makes sense because my rule says if we're multiplying the bases, we add the exponents. 4 plus negative 3 is 1. Number 3 is practically the same. We'll do this one more time. To write it in expanded form, you are going to have to do the negative exponent rule first. I would have 4 over r to the 3rd power times 2r squared. Now we're going to do top times top and bottom times bottom. It's going to be 4 times 2, r, and 1, 2, 3 r's on the bottom. Again, anything that's both top and bottom, I cancel out. And other than that, I start multiplying or counting. 4 times 2 is 8. And I have an r remaining on the bottom. 8 over r is the correct simplified version for this particular problem. And it makes sense because 4 times 2 is 8. 3 plus 2 is a negative 1, which I then put on the bottom so it's positive. If you don't have any negative exponents like number 5 here, you treat numbers like you've always treated numbers. We're going to have 2 k times 4 k. Numbers treat like numbers. 4 times 2 is 8, and for a grand total of 5 k's, because 4 plus 1 is 5. Now if we move on to a different kind of problem here, maybe one that's a little bit more complicated, we can do this one, number 14. Sorry, I'm kind of jumping around here. Number 14 says 4a cubed raised to the 2nd power. Now if you remember, exponents tell us how many times the base needs to show up. So how many times should this yellow base show up? Twice. Let's expand it. 4 1, 2, 3. That's the first time it's showing up. 4, 1, 2, 3. That's the second time it's showing up. It's 4a cubed squared, happening twice. Well, then the rules still apply. 4 times 4 is 16. And a's, I count them up, there's 6 of them. Now this makes sense for us based on the rule, because I told you that the power to a power rule kind of looks like distribution. And we'd multiply the exponent of 1 by 2 and 3 by 2. 4 squared is 16. Okay, let's look at a problem like number 18. Okay, number 18 is a quotient, or sorry, a power of a power rule. How many times do I want this base to show up? Twice. Okay, well, let's let that happen. We've got x, y to the negative 1. Ooh, yucky. Times x, y to the negative 1. Now, I don't want to deal with negative exponents in this expanded form, so I'm actually going to rewrite this as x over y to the first power times x over y to the first power. For a grand total of 4 x's on the top and 2 y's on the bottom. And this makes sense because our rule says to multiply. 2 times 2 is 4. Negative 1 times 2 is negative 2, so I move it to the bottom, so it's positive. Now if we go to the rules down here, sorry, that's not the one I want. This is the one I want. And work on the quotient rule in expanded form. Quotient rule is almost the easiest one to write in expanded form, because we just go ahead and expand it. I've got big numbers of 3 and 3, and 1, 2, 3, 4, 1, 2, 3. Any number on top of itself, 3 over 3, n over n, n over n, n over n cancels out, and all I have left is a single n. Now this works with our rule because we said treat numbers like you've always treated numbers. 3 over 3 is 1, but treat exponents like we learned to treat exponents. When we divide, we subtract. 4 minus 3 is 1. You can use the expanded form or you can use the rule. Expanded form works while the numbers are small and not that complicated, but when we start giving you things like number 26, the expanded form gets kind of crazy. So here is the expanded form for this one. Now we have to take care of these negative exponents first. So this is a negative exponent, this one has a negative exponent, and this one has a negative exponent. Those 3 pieces, and only those three pieces, are the things that are going to switch sides. So the top should now say 2x to the 4th, y to the 3rd, because it came from the bottom. And the bottom should say 3x squared, y to the 4, z to the 3, and z to the 4, right? These 2 pieces move to the bottom, this piece moved to the top. Now that's complicated looking, so let's go ahead and write it in expanded form so we can use the rules. We have the numbers 2 divided by 3, which doesn't actually divide, we'd end up getting a decimal. Then we have 1, 2, 3, 4 x's, and 1, 2, 3 y's. In the bottom I have 1, 2 x's, 1, 2, 3, 4 y's, 1, 2, 3 z's, and 1, 2, 3, 4 z's. Just like before, if the same number is on top and bottom, I can eliminate them because they reduce to 1. We'd end up with the simplified version, 2/3 x squared y z to the 1, 2, 3, 4, 5, 6, 7. So 2x squared over 3yz to the 7th power. Now this follows all the rules we've taught you when you start at the beginning. We said that when you have numbers, you treat numbers like you've always done. 2 divided by 3 is just 2/3, so here's my 2/3. And then if we have letters, we're going to take them piece by piece. My x's are divided. When I divide, I'm going to subtract. 4 minus 2 is 2. Then I have the y's. Again, I'm going to divide and subtract. -4 minus -3 is equal to -1. Which means that that -1 shouldn't belong up here. It needs to go in the denominator with a power of 1. And if we look at the z's, again, we're going to have -3 minus 4, which is a -7. Instead of z to the -7 being in the numerator, I move it and change it and put it in the denominator. So the rules make sense, but if you need to write these things in expanded form for it to really make sense to you, do it. Use the expanded form for all of these rules to make it make sense to you. Okay, last one we're going to do is number 29. There are no negatives here, so we have none of the weird flipping to do. We'll do it in regular form first and prove it with the expanded form. Now remember, if we divide, we're subtracting piece by piece. Treat numbers like you've always treated numbers. 4/3. Can't actually divide it, so I'm going to leave it as 4/3. 4/3 is 1.3 repeated, so we're just going to leave it as a fraction. Then you have the m's. We're going to subtract m to the 4 minus 2, which is 2. N to the 3 minus 2, which is n to the 1. P to the 3 minus 4, which is a -1. Now I can't leave my answer like this because I can't have any negative exponents in my answer. But only that P is going to have to move. I guess I should put my exponents there so you can see them. I think when I prove this with expanded form, I'm going to have 4m squared n to the first over 3p to the first. Let's see how we do in this expanded form. We have 4, 1, 2, 3, 4 m's, 1, 2, 3 n's, and 1, 2, 3 p's. 3, 1, 2, 1, 2, 1, 2, 3, 4. We start crossing some things out. Can't cross out 4 and 3, so they get to stay. But I can cross out m over m and m over n, n, p, p, p. Collecting the things that I have left, in expanded form, I would have 4 m squared n over 3 p. And guess what? We got the same answer whether we used expanded form or we used the regular form with the rules. If expanded form works for you, make sure they're positive when you expand them, and then go for it. You are more than welcome to use your exponent rules like this. It just might get ugly. There may be problems that have an exponent of 60. That means you'd have to write 60 x's down. So use it to learn the properties that will make your life easier. Learn your mad spam rules, learn the negative exponent rule, learn your T-bow rules. Hopefully this helps. Y'all have a good one.